Okay, these notes are particles and mass. Okay, in order to convert between particles and mass, we need to do a double picket fence. We also have to use the full complete mole bridge. Now, in previous notes, I gave you half a mole bridge for each time. So when we did particles to moles, that was one half of the mole bridge, and then moles and mass, we did the other half of the mole bridge. Now we got to put it together. Hopefully you picked up the mole bridge in class, so you can use it. We need to use the whole entire thing. Okay, in this example, it says how many atoms are in 6.20 grams of helium. So we are going from, oops, this would help if I had my pen on, mass to particles, because atoms are particles. Okay, so if we look on our mole bridge, we're going to be going from the left side of the mole bridge all the way to the right. Now, before we even start this, we need the molar mass of helium. So 1 mole of helium is 4.00 grams of helium. Okay, if you look on the mole bridge, going from mass to moles, it says we divide by molar mass. So I'm going to put helium there, and I put the molar mass on bottom, because that's what divide by means, right? Well, that makes sense, because now your grams of helium are going to cancel. Next, it says going from moles to particles, we need to multiply by 6.02 times 10 to the 23rd, which means it goes on top. And that makes sense too, because we need to get rid of the mole, so we need to put mole on bottom. Okay, now to get the correct answer, you've got to put this into your calculator correctly. Or you can do it by hand if you really want to. But let me show you how to put it into a graphing or a scientific calculator correctly. If you put everything in parentheses, you will always be assured of getting the correct answer. So you do 6.20 and 6.02 times 10 to the 23rd and parenthesis 4.00. And if you do it exactly like I've got it written here in your calculator, you will get the correct answer, which is 9.33 times 10 to the 23rd atoms of He. Now, this is but using one step, using a double picket fence. The next method I'm going to show you is using 2 steps. Basically, you're going to do the first half of the mole bridge, then the second half. So each step goes halfway. Okay, so the first step in this one is to go from mass to moles. That's what our our mole bridge does, right? It goes from mass to moles. Then we divide by molar mass. So we're going to take the 6.20 grams of He and put 4.00 grams of He. So this is exactly what we did yesterday. So we're going to incorporate that first. And when we do that, we get 1.55 moles of He. Now the second step is going from moles to particles. So we're going to take the 1.55 moles, so the moles we calculated in the step above is what we're going to start out with. And then going from moles to particles, we have to multiply by 6.02 times 10 to the 23rd. So this is what we were doing the beginning of the week, Monday and Tuesday. Okay, so we've kind of incorporated both things. Now when we do that, and you guys know how to do this on your calculator, it does come out to be the 9.33 times 10 to the 23rd atoms of He. Okay, so you got a 1-step method and a 2-step method. Okay, this next example. What is the mass of a sample of KClO3 that contains 4.21 times 10 to the 21st particles? So here we're going from particles to mass. So we're going the opposite way over the mole bridge. Once again, we do need the molar mass of KClO3 before we can start. Okay, when you add up all that, so 1 mole of KClO3 is equal to 122.55 grams. Okay. Now, we're going to start with our 4.21 times 10 to the 21st particles of KClO3. Now, when we're going from particles to moles, according to the mole bridge, we divide by molar mass. Divide by 6.02 times 10 to the 23rd. So we're going to put that on bottom, which makes sense because we want to try and get rid of particles. And now we have 1 mole. Okay, and then going from moles to mass, we need to multiply by molar mass. That means the molar mass goes on top, which makes sense because we now need to get rid of the mole of KClO3. And the only way to do that is if it's on bottom. So those two cancel and those two cancel. Now, once again, to put this in your calculator correctly, you need to put it in the calculator correctly to get the correct answer. Okay, put everything in parentheses. So you would do 4.21 times 10 to the 21st, and put the next parentheses, 122.55, hit the divide by button, and then put the bottom in parentheses, the 6.02 times 10 to the 23rd. And when you do that, you get 0.857 grams of KClO3. Okay? Once again, this is using one step. You can also use 2 steps, just like we did in the other problem. Okay, step 1 is going from particles to moles. Okay, so we're going to start out with 4.21 times 10 to the 21st particles of KClO3. And we put the 6.02 times 10 to the 23rd particles of KClO3 on bottom with the 1 mole on top. Now, the thing is here, you're going to get a whole bunch of numbers. You want to go at least 4 places. You want at least 1 more or 2 more significant digits than what you have. In the first example, when you take the 6.20 and divide by 4, you get 1.55. There are no other digits. So that's about as best you can go. Here, we can go a couple. I'm actually going to put 5 significant digits. The more you put down here, the better. Okay, because that means you're going to be putting it into your calculator. And the more digits you have in your first calculation, the more accurate your second calculation. Because when you do it all at once, your calculator takes it into effect. So it has all those digits. Okay. Step 2 here is going from moles to mass. So according to the mole bridge, we are going to multiply by molar mass. So we're going to take 0.0069934 moles of KClO3. And we're going to put the 122.55 grams on top, because we are multiplying by molar mass, and put 1 mole of KClO3 on bottom. That way your moles cancel. When you do this, you get 0.857 grams of KClO3. Okay, so on the problems we do in class tomorrow, you get to choose. You can either do the 1-step method or the 2-step method. Doesn't matter. As long as you get the answer and you show your work, that's all I ask. Okay, so have a good night. Bye.